Well, hi folks, this is Darren with My RV Works, and today what we're going to be doing is finishing up a three-part video. This is the video on my dump trailer where the first video, and we'll make links up above, but the first video was installing a battery box and talking about all the things involved in batteries there. The second video was all about the disconnect switch, and on that one we did some in-brush, talked about wire gauges, designing a circuit to handle the current ampecities going through it. And in this video, the third series of this video is I'm automating my dump trailer where I can control the dump bed going up and down remotely from in my truck, cab, or walking behind the trailer or a distance, because the tether they give you, hey, we got a kitty cat here. The tether we give you is only so long and you couldn't really walk around and see stuff. So now this video was made for our sibling channel. We call that channel Life Koepp Simple, or the Koepp Simple channel. It's our last name, Koepp, rhymes with step. And so we've got a lot of content that we wanted to share. We bought some property and we're doing some improvements on it, and we figured we'd just share those events and stories with you guys. And this was a video that we made for that channel, but it does have some application possibly that might work with the My RV Works side of things, RV type stuff. It's a dump trailer, not an RV, but we still kind of play around with stuff in there. So that's the nature of this channel, or that's the nature of this video. So if you like this kind of content, you might want to check us out on the Koepp Simple side, because we built a pool, we're building a driveway, we'll be doing some improvements on the home. We've got some in-ground utilities that are going in and that type of stuff. So that's the kind of stuff we're covering on there. Okay, so anyway, so let's jump into the final third part of this video and hope you enjoy it. Now, a little side note, the video runs kind of long, but while I'm making the wiring diagram, I really took some time to really develop the ideas behind the wiring. The color wires change, like in black is positive and then black becomes negative. And so the color codes change, and I really try to take my time and slow down. I have a grease board drawing where I'm drawing on the grease board, and I'm really trying to develop the schematic, and I'm really purposely trying to go slow and not like blaze right through stuff, so it really kind of makes sense for you. And at the end of the video, I make you guys an offer if you're interested, so you can kind of watch the end and see what the offer is. So anyway, hope you guys enjoyed the video. Thanks for watching, and happy trails. We'll see you down the road. Bye. Hi folks, welcome to part 3 of a video that I started that I broke into 3 parts, ergo part 1, 2, and 3. Part 1 and part 2 will make links to, and the purpose of these videos is we've got a dump trailer here, and I wanted to make some modifications to it. There was 3 modifications that I wanted to make, and I divided them into 3 different videos. The first modification I wanted to make was I wanted to put my battery in a battery box, because when it came, it didn't have a battery box, and I wanted it in a battery box. So the first part of this video was all the efforts that we had to go through to make that happen. So that's the first part of this video. The second part of the video was or part 2 of this series was I wanted to make a disconnect switch. So when the trailer is parked in the mode that it's in now, and we have it propped up on its safety prop, I can remove a key and render the motor totally inoperable. Okay? So that was the second part. On the second part, we also did an amp draw on the motor that elevates and retracts the dump, and we talked about wire gauges and ampecities and wire ratings for that. That's all in video 2. This video, part 3, is going to be how to modify this trailer so that you can control it with remote control. So I've got a remote control thing, and we're going to get real close with these things. It's going to have an A and a B button. I'm going to make A the up mode to dump, and I'm going to make B the down mode to retract. And the purpose I'm going to do this is because when I am dumping my trailer, the manufacturer has a really nice, looks like a NEMA 3R or a IP65 type enclosure. I haven't tested it to those specs, but it looks like a nice industrial rugged control module box. Pendant is what you will. And it's magnetic, so it sticks on the side. So that's really nice, and I like this box. I have nothing against this box. They even have a nice strain relief on the end. I could probably get a longer cable, Because what I want to do is I want to be able to see when I'm dumping. I want to be able to see in the back. If as I'm dumping, am I hitting a tree limb? Is everything out of the body of the bed? But another thing I'm going to do is we can set the chain so we can dump it as we're driving, and it'll leave a nice bed of gravel behind us if we're pouring gravel. And so this won't even reach the cab of the truck. So for those reasons there, I wanted to make a remote control. Now I picked this one not because it's any better than any of the others, but according to the specifications, it has a good range. And I went with a good range because I'm in my truck. If the windows are all up, well, they won't be up, okay? But anyway, I want to make sure we've got enough range to cover sending the signal to up and down to this. So I didn't get one with a short range, I got one with a long range. Okay, so this video is all about installing that. Now, what we'll be doing, this is the pendant that they shipped it with, and this will become the pendant that I'm going to wire in parallel with this one, okay? So this remote controls this one, and these buttons control this one. I think you understand that. We are going to wander into some wiring opportunities where we're going to be able to exercise some of our inner control automation type thing. And my plan is to take you to a grease board and draw out this circuit and explain to you how this one's wired and then how we're going to have to wire this one. To make this work, we're going to have this module control these 12-volt relays. And when I get into the grease board drawing, I'll explain the reason why that is. And hopefully I'm able to convey to you how to do this yourself. And I'll make links down below in the description for all these parts if this is something that you want to do to yours. So that's the nature of this one, of this video, part 3. Battery box, part 1. Disconnect, part 2. This one's part 3. So we can break it up even more granularly. And when you're dealing with these circuits, there's 2 parts to it. There's a power circuit and then a control circuit. So we might say that video 2 was the power side of the circuit. And we talked in video 2 on the gauge of the wire, the disconnect switch. We are going to be adding a inline fuse to that, but that's the power side. This video is going to be the control side. What controls the motor, okay? So let me take you handheld and bring you over here and show you some of the wires that came from the factory. And then I think what I'll do is I'll go on to a grease board and I'll try to draw some things and show you, I'll reconstruct the wiring on a grease board and then show you how we're going to tie in with this new module. Okay, so let's go, I'm going to grab you and take you around and show you some of the wires, and then we'll go to the grease board, okay? Okay, so a little bit of show and tell. Let's start with the pendant wire. Okay, so what we have here, this is you can disconnect the pendant, which is another feature that you can do to render your dump trailer inoperable, is just take the pendant with you by unscrewing this. The other end of it is right there. So when we go into this pendant, we'll see that there are several different colored wires. There's a black, a brown, a green, and a blue. Let me come around the other side. So now we're on this side. So when we take this pendant wire, okay, this is the one that goes to the pendant. I'm calling that thing a pendant. If you were to look right here, you see the brown wire, and then if you were to go behind this lug, you're going to see the black wire. So this wire right here that my finger's touching is 12 volts plus coming from the battery. It's always hot. The black wire is going to go into our cord to here. So that means we can say that the black wire is, in our parlance, we would say that the black wire is wetted. It's wet, meaning it's got voltage. So in controls engineering, we'll say the wire's wet. Okay, so the black wire is the wet wire. The black wire is a hot wire. Okay, so the black wire comes up here, always having 12 volts on it, always sitting on this switch. It's when you push one of these buttons that you are going to take the power that's in the 12-volt black wire and feed it through the switch, and you're going to be coming back down the wire over to here. Now, there's two things that need to happen when you push up or down. The first thing that needs to happen is we need to start our motor. The second thing that needs to happen is we need to engage one of these two solenoids. If we engage this solenoid here, we're going to extend. And if we are, I'm going to go up, I'll just use the terms up and down. So if I engage this solenoid, that is to say, if I put 12 volts on the green, then this solenoid will engage. And if I were to put 12 volts on the blue wire here, then I will engage this solenoid, which coincides with down. But it's not enough just to energize these solenoids. We also need to start our pump. And here's our brown wire. So 12 volts is on the 12 volt plus. Follow with me on this. So we're going to pick up our black wire that's going to be wet. Again, we're going to use the term wet. So we're going to put 12 volts on our black wire. Okay. Black wire is going to come here. Black wire is a wet wire. Where that comes from, I don't know, but I was a controls engineer for over 30 years, and that's just what we call it. So let's just use the terminology that I'm familiar with because it makes sense to me. When we push this button for down, we need to do two things. The first thing I need to do is engage a solenoid here to start my pump. And the second thing I need to do, if we're going to go down, is engage my blue wire to open up that valve so that my hydraulics flows the direction we want it to flow. If I were to go up, there's two things I need to do there. I also need to engage my brown wire, which is my motor. But on this one, I need to engage the green wire to make my hydraulics go that way. So the motor is only going to go in one direction, and it's these two solenoids here that determine the flow of the hydraulic fluid. The challenge then is in this pendant, in here. When we push these buttons, we want to make it so that the brown wire gets energized regardless of which one we press. So we want the brown wire to be energized whenever button's pressed, but we only want, when we go down, we want blue, and when we go up, we want green. So that, as I say, down is brown and blue, and up is brown and green. At no point would we have blue and green. Okay. 4 wires. Black one is always hot. When we push our switch, we're going to come back brown and green or brown and blue. If this were a relay, it would be what we'd call a double pole single throw relay. And I'm going to draw a picture on the grease board here and kind of do a pictogram on what that would look like. Okay? So now that you've seen the circuits, it's really a simple circuit. Now you do have a couple other wires here. You have, here we have a battery charger, came with the trailer, and then they have a black and a red, okay? And that's pretty simple. Red goes to plus, black goes to minus. Actually, it's black with red stripe, or it's just where it was peeled off. Not to be confused here, because here we have the 10 gauge black, which is chassis ground. Here we have a black, which is the minus to the battery charger. We have a white, okay? So the negatives on our battery post are going to be predominantly black and white. But remember, when we get down here, the plus wire that feeds this is black. Not to be confused. So you don't want to get colorblind and just say, oh, well, it's a black wire, therefore it's minus. That is not a correct statement, because when we get in here, it's the black wire that's the plus. There is no red. There's a black, brown, green, and blue. So black is plus when you get into here. Okay? So that's our battery charger wire. Then we have another circuit here, that's this blue, that comes in through our fuse here. This is our breakaway circuit. The breakaway circuit is the one that is over here, that is connected to our trailer, our tow vehicle. And if something were to happen to our hitch and the trailer were to fall off the tow vehicle, then this gets pulled out and we need to engage the brakes. And the brakes get their power typically from the tow vehicle, but inside of this switch, there's two contacts. And when this pin gets pulled out, those two contacts close. And here's our two wires right here. And when the two contacts close, we're basically connecting these two wires. So one side of these wires is always 12 volts hot, and the other wire is basically a home run to my brakes on the trailer, keeping them as separate. When the cable gets pulled out, they close. Therefore, I'm sending a straight up 12 volts right to my brakes on my trailer. What I'm going to do is, we've got My RV Works. We own that company as well. And I made a video on that channel on how these breakaways and brake cables work. So I'll make a link to that video. So if you're watching this and you want to know how to wire your breakaway, you can watch that video. Okay. So that's all the wiring we have here. This is all the control wiring. So we have the brake circuit for the breakaway. We have the battery charger. Okay. And then we have the control wiring here that controls the solenoid. And when the solenoid is engaged, here we have the big wire right there. And then when this guy gets engaged with little bitty 12 volts right here, he passes that voltage onto this red wire, the big one, and energizes our motor. Okay. And then now we also have, so we were talking about the blue and the green wires here, but we also have a black wire on the bottom and a black wire on the bottom. Now these two black wires here are going to be bonded to chassis frame. Our battery here is bonded to chassis frame, and it's done on 2 points. This big 10 gauge wire is bolted right down there, okay? But also, the really big 10 gauge wire is bolted to the block of the pump manifold. So as long as these two black wires on the bottom down here are bonded to the block manifold, therefore they're bonded to this big wire, therefore they're touching the negative of the battery. So we've made a complete circuit. The goal is to go from positive, to go do work, end up on negative. We're picking up our circuit on the black wire here. Go through our pendant where the circuits are switched. We're coming in hot black, leaving on brown or green, or brown and green, or brown and blue. Brown always, but then one's green, one's blue. Coming back down, brown will energize our solenoid, and then here we have green or blue, and these will work because green in this instance is 12 volts plus, and then right below it I've got it's a black wire, which is negative. It goes to the frame. Here we have blue, black is negative, goes to the frame. Here we have brown is the plus coming back, and then internal to this style of solenoid, it's got this metal frame that it's in, and the metal frame is the ground. So you don't wire a separate ground circuit to this solenoid when it's bonded to this motor. This screw right here is the ear that holds down the solenoid, and as long as this motor is grounded, and as long as the motor is grounded, which we know it is because of this big black wire right here, and as long as the solenoid is attached to the motor, therefore it has continuity, therefore it's grounded. So all we need to do is just energize the brown wire right there, and then this guy engages. Okay, so let me take you into a grease board and reconstruct everything that I've just shown you here on a drawing. And it's important to do that step because, let me walk around and grab that box over there. Hold on. Because if we need to first understand that circuit, here we have 12 volts plus, 12 volts minus, normally open 1, and common 1, normally open 2, and common 2. And here we have white, brown, green, yellow, black, and red. And we need to make sure that we understand how these wires are going to work. And then we're going to talk then about why it's necessary to use a 12-volt relay with that. Okay, so let's go to the grease board portion of our video. And like I said, the first thing, I will reconstruct this drawing. I will reconstruct the schematics for this, and then I'll show you how we're going to integrate this into that so that electrically everything works, and then we should have success when we push our remote control button. Okay, so I've moved you here to my grease board. And now, remember what the colors were, right? On the pendant, we had a black, a brown, a green, and a blue. So I'm going to use these for the colors, okay? Now, I don't want the dark blue to be confused with the light blue because I needed to come up with a color that I could use as a box. And so I'm going to make light blue be the box, okay? So we have, I really want to use black, but I'm going to use this blue wire. The blue, this is going to be my jacket to my cable, okay? So here I'm going to have, this is the cable that's going to my pendant, okay? Now, this is our pendant. That's a yellow box, okay? And then here I have the two switches, right, up and down. And then over here, I've got a black wire, a brown wire, a blue wire, and a green wire, okay? So let me take this part of it, the drawing, and kind of show you how it has to be in order for it to work. Okay, so I'm going to erase this right here. And for clarity, I'm just going to use black because black's going to show up a little bit better, I think, on a whiteboard. So I'm going to make this is Darren's version of what a relay would look like, okay? So I always do it like that, okay? Or a switch. So that is to say, if I have power coming here and I push my switch down, then it carries on. So that's the drawing that I'm going to be using for a switch, okay? Hopefully that makes sense. Now I said in order for this to work, that pendant needs to be a double pole, single throw circuit. So double pole, okay, double pole. So this would be what is required to make it go up. And then we need it to go down. And this is going to be what is required to make it go down, okay? Remember, it's this black wire here, so I'm using black to show my drawing, but we can basically put dashed lines, and what those dashed lines represent is that when one of these levers goes down, they both are bonded together, both levers go down, making it a double pole, okay? This black wire, remember, now let me show you a trick. If you're watching this, I'm going to show you a trick. We're going to use these colors here. So if you take the colors, all these colors we're using, and you take the first letter and the last letter, it's a shortcut for color coding, okay? So black would be BK. I'm going to stick with the black pen in my hand so I don't have to keep switching. Brown, BN. Blue, BE. Green, GN. Okay, so if you see me using these initials here, that's what the colors are going to be. I'll just leave those up there. Let me move my jacket out of the way. So remember, the wire coming out, this black wire, is going to be 12 volts plus. We call that the wet wire. So he's 12 volts plus and he's black, okay? Now what we want to do is we want to wet this side of every one of these contacts. So I don't know exactly how they have that pendant wired. They might have copper conductors, I don't know. But circuitry wise, follow with me on this. We're going to bond it to here. We're going to daisy chain to this one. Let me change colors. I think if, I don't want to keep changing colors on you guys. But what I do want to do, let me make this red because I don't have a red. Here, let me do this. I'm going to make my double pole switch red. How about that? This is up, this is down. Now I can use my black. Okay, so we're gonna come in with 12 volts plus, right? Because on that pendant, the black wire was 12 volts plus. We called it the wet wire, and he's black. What I need to do is I need to daisy chain all of those, don't I? None of them are pressed down, so that 12 volts is just sitting on one side of my switch, isn't it? And I'm gonna put my little dash lines here, okay? So 12 volts is just sitting on this switch. So let's take our brown. So if someone were to push the up button, both of those contactors are going to go in. Well, we know that brown, BN, was going to go engage our pump solenoid. But if somebody were to push the down button, we also need that pump solenoid to be engaged. So we're going to daisy chain that, aren't we? So what that is to say is, if 12 volts is coming in here on the black wire, and someone were to push my up button, then these contactors are going to touch. And because they're all daisy chained, I'm going to get 12 volts going through this switch out of brown. Likewise, if somebody were to push my down button, 12 volts is wetted on this side, just waiting to go. There are horses in the gate. And if somebody were to push my down button, then it's going to pass through here, and I'm going to get 12 volts coming out of my brown. Okay? And then I think it's very easy to see. I don't remember if, I think blue was down and green was up. I think. I'm pretty sure that's what it was. So I'm going to use this for green. So this one was up. GN. I'm going to call that up. Okay. And blue here was down. Okay. So there's our 4 wires. Black, green, brown, and blue. Those were the 4 wires we had. Here's how they must be wired inside the pendant in order for it to work. If it wasn't a double pole, and I energize brown every time, then it's going to backfeed, and it'll be up and down every time. Okay? Now, I'm gonna make this one say motor for our pump. That's supposed to be a T. Bear with me here. So hopefully that makes sense. We've represented the 4 wires here. We've represented how they make it through the switch. I'll tell you what, let's do. Let's take the pendant apart. I haven't done that. Let's take the pendant apart and see what they've done here. It should be able to reach here. Okay, so I've got a little tray to catch my screws. Okay, looks like I've got a little rubber seal. Okay, so let me come over here with you guys. Show you. I want to make sure you can see this. Okay, if I hold it there. So here's our black wire. Remember, black was wet. And looks like black is going to be touching that bridge right there. So let's take a look at this. So if I get this just right, I'm going to push the down button. Okay. Now the black wire is a wet wire. Okay. Let me see if zooming in does any good. There we go. Okay. We're trying to get right in there. Okay, so you see how it's making contact right in there if I get that angle just right? So that is to say that the black wire, when I push the button, I'm energizing this outer plate, which is bonded to the brown wire. Okay? So this whole plate here, when I hit the black wire, or the black wire is wet, right? When I hit one button, I'm bonding the black to this frame here. And when I hit the up button, let's see here if I can get, okay, you see I'm hitting the up, that's the up button right there. And when I hit the up button, I'm also touching black to this plate, which is brown. So that is how black 12 volts is going to brown motor solenoid, by hitting that. Now let's see here. There's blue and green on this side. So let me do it this way. Okay. Let's see if I can get in there. Okay. Yeah, good, good, good. See, you can see that contact point right there. So when I'm hitting down, okay, when I'm hitting down, I'm making contact. So not only am I making contact with the brown plate, but here is where I'm making contact with the blue wire for down. And then likewise, when I hit this, you can see that contact point making contact. I'm touching the green wire. So my drawing up there, let me zoom you back out. What they're doing in this switch is basically what I'm showing you in the drawing, okay? 12 volts is going out brown regardless of which up or down switch you push, okay? And then 12 volts is going out of only the green one or only the blue one on that. Now I wonder if you can push them both at the same time. Okay, that's interesting. On this, you can push them both at the same time. I wouldn't recommend that because the pump would then get the signal to go up and down at the same time. In controls engineering, we have mechanical interlocks so that it's mechanically impossible to push both buttons. And we also wire them so there's electrical interlock. So if you override the mechanical interlock, electrically, you can't do them both at the same time. It'd be like a reversing motor starter would be an example there. You wouldn't want the motor to go in both ways. So there's a mechanical and electrical interlock. I just noticed on this switch, it is possible to push both at the same time. So, interesting, okay? Anyway, so we've just shown that the switch is in fact wired this way. So let me put this back together and we'll carry on with, okay. So that's how this switch, I'm gonna do this later, okay? So now let me show you how we're gonna tie in our remote control circuit to this. Okay, so I took a second to redraw this. It was in red, I made it in light blue, because when we start talking about this module, they have a red wire, and I wanted the red to be available for the red wire. So it's the same drawing, black coming in, daisy chain, so this side's all wetted, okay? And then this side are the ones that'll be being connected as the buttons are pushed. Okay, so we're clear on that. On this module, I don't know what module you're going to get. This module gives me two normally open relay contacts. Okay? They're single pole, not double pole. So when I push my A button, I'm going to, let's just, maybe there's a way to configure this thing, but when I push A, let's say A is my number 1 circuit and B is my number 2 circuit. So here, let me come around here and we'll go through this together. Okay, so if you look here, you'll see red is 12 plus, black is 12 minus. Now here, it's black is 12 minus. Up there, black was 12 plus. So we need to be, again, don't be colorblind just because a wire is a certain color. Same with people. You shouldn't judge a wire by its color or its people. Yellow and green are going to be my number 1 circuit. So that is to say, yellow and green, I got yellow on one side and green on the other. And when I touch them together, we're going to go, this is going to make a connection. And my number 2 circuit is brown and white. And when I push my B button, brown and white are going to bond together. Okay? And so here's our colors here. So what do we have there? Red and black. So here I have red and black. Okay. The next circuit is, what does that say? Yellow and green. So here's my yellow and green. They're going to be basically these two wires will touch together when we hit our A button. And then I've got white and brown, and these two wires will touch together when I hit my opposite button. Okay. Because this is a single pole, not a double pole, all I have is just what this gives me. Let me just draw it real quick. I'm just going to do it in black because I think black shows up good on the whiteboard. What this is going to give me basically is that. Okay, that's what this box will give me. So I'm going to call this one A and I'm going to call this one B. Okay, and so in order, if this box is only given me just a single pole, remember this is a double pole, and they have triple poles and 4 poles, and it gets crazy. So this is a single pole single throw. Okay. Since you've come with me this far, here's another little thing on relays and switches. This would be a single pole double throw. This is a single pole single throw. So what that means is I have a wire here, a wire here, and a wire here. And so this would be the normally closed side, and this is the normally open side. You might see in controls, you might see NO dot, or N.O, N.C dot, there's periods in them, and that's how you know it's that. So this is normally closed. What that means is if there is a relay and, okay, so this is our relay. I'm going through this really fast, and maybe I'll do a whole other thing. If you want to know more about relays and controls and engineerings, let me know in the comments, and I'll do a whole video just on relays and controls and things like that. So this is called the coil. When the coil is energized, it pulls this down. And so the way we decide if it's normally open or normally closed is what's the condition of the switch in its resting state when it's not energized. Now, normally open or normally closed usually refers to like relays and things like that, okay? It could resort to a pendant switch. So you would say that it's normally open because the spring is pushing it back, okay? A light switch in your house does not have a normally open, normally closed because it's either in one position or the other. So you would not see normally open, normally closed on a switch like that, but on a pendant where it's spring loaded, that could either be a normally open or a normally closed switch depending on where the spring is pushing it. The spring is either pushing it like an emergency stop button, we call those e-stop buttons. Those are wired normally closed, but most of your switches are wired normally open, okay? So I just wanted to take a moment and talk about NC and NO. So this would be a double pole. Let me clean that up a little bit. Okay, there. So when you have, in other words, the voltage coming in here could go out either normally closed or normally open. You can also do some fancy controls wiring and wire them backwards where you might have two different circuits feeding this thing and you come out. This one's called the common circuit, but it doesn't have to be the one that feeds the circuit. It could be the one that receives from either circuit A or circuit B and comes out this way. So you could wire relays forwards or backwards. It's really kind of exciting. So this one being a double pole or a single pole double throw. This is a single pole single throw, and this one is a double pole single throw. It has to do with how many throws. A switch is called a throw. How many throws? Okay, so we're going to get rid of all that. What this gives me then is just a single throw. Well, that's not going to work for our remote control, is it? Because if I wire, what am I going to do with my brown? I can make this one my green circuit, and I can make this one my blue circuit, okay? And that's exciting, and that's good, but my pump's not going to work. Oh, great, well, let's just take our brown wire and wire it into both. Well, then what's the point of the whole thing? As soon as you push the button, it's going to energize everything. So what we need is we need to make it be a double pole, okay? And so I'm going to use this, and I see it's coming apart right there, so I might need to take this apart and work on it a little bit. What we're going to do with this is I'm going to use this as a wireless input feed, if you will, okay? And I'm going to have that control these relays. So this module's purpose in life, when it energizes my single pole for up, which is A, or when it energizes a single pole for B, which is going to be down, really what you're going to be doing is energizing my two relays here, okay? So it's this and this working together that's going to give me my brown and green. This one's a brown circuit, this one's a green circuit. And then here I have brown and blue, okay? And like I said, I think I mentioned already, if this is something you want to do, I'll make links to all these things in the description below. And you can go shopping and get these things as well. So hope that makes sense. If you were to have gotten a wireless switch like this, if you could have found one that was a double pole single throw, then the switch would have been like that. And then we wouldn't have had to have done this. Does that make sense? But because the switch is a single pole. Great. Well, when he closes this one circuit, we're going to have it energize both of these relays at the same time. Okay, so let me show you how that, let's develop the circuit together to show you how it goes. Now the groovy thing about this is that they slide together. Okay, so they slide together, and they all will slide in together. And so when I put it in the front box, it's going to be all together as one. Let me get my relay down here. So I'm going to erase this, but we're going to recreate this. But I wanted you to see that the remote control part is a single pole, single throw, but we need a double pole. Okay, so now that we've discussed that, let's start to, now that we understand the circuit of this, let's understand the circuit of this. Now these on the back have numbers on them. Okay, so again, I'm going to continue using black because I think it shows up really well. So here I have an 85 and an 86. Okay, so I have these little pins. This one's going to be 86. This one's 85. Then up here I've got a 30. And then at the bottom I've got an 87. So this pin is sideways and these two are like that. Okay. Now when I look at the top, so let's reference this. Let me come over here and show you how these numbers work. Let me zoom you in a little bit. Okay, let's get you focused. Okay, so there's my number 30 here on the left. He's going to go and look at my drawing. He's going to basically be a switch that's open, but he's going to come out of 87 right there. Okay, and then there's my coil, and we're going to come in on 85 and go out on 86. So 85 and 86 is my coil. Okay, so when I energize 85 with 12 volts and 86 with minus, then this thing will basically, there's my finger, close. Okay, and that's that circuit, and whatever is sitting on 30 is going to be coming out of 87. Okay, so let me zoom you back out. So there we have our circuit with these things, and so 85 and 86 is my coil, 85 and 86 is the coil. So this is my coil voltage. So when I draw coils, I make them like this. Okay, that's a coil. And so we can, let me move 85 to the outside. There. So this is going to be my coil. Okay. And then whatever I put in on 30, when the coil's energized, he's going to come out on 87. Ergo, an electric switch, we call these relays. Relays, solenoids, contactors, they work on the same principle, but based on what they're controlling, AC or DC, and how much current they're passing through, we call them different things. It might even be called a motor starter, okay? So in order for this to make sense, we need to understand what the wire colors are, okay? So let's see how this is oriented. It goes like this. Okay, so it looks like the black wire is 85, so he's a black wire again. Let me get rid of that. Black. The white wire. Now, what am I going to do with the white wire? So I'm going to make white pink. Pink is going to be my white wire. So this is going to be my white wire, WE. Okay. Black and white are the coil voltage for these small relays. Leaving, let's see what color we got here. Blue is 87 and red is 30. Okay, making this one red, RD, and then we have a blue here, blue out, blue. Okay, so we can make white. We'll make white our chassis ground, okay? Okay. So that is to say, when I put 12 volts on this black wire, it's going to close this, and whatever's sitting on red is going to come out on blue. When I take the 12 volts away from the black wire, this is going to open, and then whatever's coming in on red will not go out on blue. It's a switch, okay? So now we know our color codes. I hope that was added value to you. So we have red and blue. Let's see here. I'm going to call red. I am going to call this red wire common, RD equals common, I'm going to call blue here normally open. This one's black. I'm going to say 12 plus. Pink is white. WE, I'm going to make him ground. Okay? So now we've figured that part of it out. This is the schematic for these little relays right here. So I'll put that in a black box. Now we have determined what the color coding is for these relays. Okay? Now we have to figure out the color coding of this. So here we have, now remember in my very beginning I was using, I think, this color as my wire. So here we come with our wire. Okay, and let's get all my colors together. I've got a red, a black, a yellow, a green. I'm going to use lime green because I don't want you to confuse it with the green out of that. A brown, I'm going to use an orange for brown on this one. And a white, I'm going to stick with, hold on. I'm not going to use this black for this one. I'm going to use purple. Okay, as long as I keep my colors consistent. I feel like I need another color. So red is 12 plus. On this, red is 12 plus. Remember on this, black was 12 plus. So we're going to use, is this magnetic? Oh my gosh, that's magnetic. That I just learned that, that's cool. Black here, I'm going to use as purple. You see why, because that. And then we have yellow and green. These are our yellow and green circuits, and then I'm going to use brown and white. Brown and white. Okay, so those are the colors we're going to use for this, okay? So all these wires, there. It's like a flannelgraph in Sunday school. So all these wires are coming out. With me? So we're going to keep these two together, and these two together, and those two. I'm going to erase this part. With this here, let me move these. Boy, those are good magnets. With this here, we need 4 of those, don't we? So I'm going to use this blue color to make 4 of those relays. Okay, so what we need to do is take these wires and put them into these wires here. So I'm going to make that be my image of one of these relays. Okay, so this is the power side, this is the control side, right? Okay. There. What we have here, this is the power side, this is the control side. So black was 12 volts plus to my coil of my relay. But I need to wet all of these guys. So we're going to wet them with red. So that is to say we're going to take all of our red wires and tie them all together. Where did red go? Red's up here. Okay, so we're going to make red common, right? So we're going to pick up 12 plus. Up there it's black. Here it's red. So we're going to daisy chain all of those. Okay. And then normally open is blue coming out. So we're going to use this blue. Well, hold on. We're not going to use the blue. Remember our circuit up there? There's a divider. This is the up. Let me do it this way. This is up. This is down. Okay. So we're going to take this brown right here. and we're going to daisy chain, and that's going to become motor. Brown. Then we're going to take green, same green. He was up. This guy's up. Green, up. We're going to take blue, the same down from here. We're going to grab this guy. Blue. So we're going to be wetting one side, coming out on green. So, okay, so we need to energize these at the same time. So this guy was brown and white, green and yellow. So in this wiring here that goes up to our pendant, here's going to be our wire going into this pendant here. Red and black. Red was going to be 12 volts plus. We can pick that up from, remember where this black wire was bonded to on the solenoid on the motor? So we're going to pick up red on that. Okay. And then this black wire coming out of this wire is 12 minus, and we'll just bond him to the frame. That just takes care of these two wires. But we just sent 12 volts into our pendant. Now, we need to take yellow. Where did yellow go? I'm using orange for yellow. Where did yellow go? Oh, they're up here. No, yellow's right here. I need to take my yellow wire, because yellow was common. I don't know if you're going to be able to see this, but yellow also needs to be tied into that 12 volts so that yellow is always hot. And while we're at it, let's make brown, which I'm going to use as orange, also needs to be tied in. So that is to say, brown, yellow, and red going to this module here all need to have 12 volts on them. Yellow, brown, and red in this circuit all need to have 12 volts sitting on them. Red to power a module, yellow and brown to sit on one side of that relay. When the A button is pushed, yellow is going to come out on green, and I want to hit my relay here and daisy chain to here. And this one's going to be the white wire. Remember, white was going to be pink. The white wire coming out is going to go to this coil and daisy chain to this guy. So inside of this module, I've got a situation like this where everybody's just sitting on one side. That's why I have to have power to my yellow wire and my brown wire. 12 volts red needs to be powered just to power the module. But the yellow and brown, it says on here, yellow is, well, they say yellow is normally open 1 and brown is normally open 1. So we need to just sit though, they're just normally open. When we push the A button, then we're going to come down on green, and when we hit the B button, we're going to come down on white. So by energizing the green wire, I'm energizing both of these coils, both of these at the same time, together. By doing that, I'm energizing green and brown. And then over here, when I hit the B button, I'm energizing both of these coils. And then I'm energizing, because they're all wetted on one side, the brown and the blue. And then I have that. So what we're going to need to do then is all of our red wires, we can snap all these together. All of our red wires, we need to tie all of our red wires together to be 12 volts plus. that leaves these wires down here, and they are going to be white wires. So again, we're going to use, see, the problem is the color codings are getting messed up. But all of these, what's going to be ground? I need ground. Ground was this white color right here, but that was also that one. So all of these are daisy chained to ground. So that is to say that the coil voltage, all of our whites, okay, so all of our reds in this schematic, all of our reds are bonded to 12 volts plus, and all of our whites are going to be bonded to the chassis frame. So then that leaves the normally open, and where was black at? Okay, the coil voltage. So that is to say that leaves these two blacks are going to be the coil voltage coming from here, and these two blacks, like these two blacks are going to be up and these two blacks are going to be down. And then so that leaves the 4 wires. Okay? These 2 wires are going to be brown. This brown here to the solenoid motor. This wire will probably be green to go up, and this wire will be blue to go down. All right, I think I made a complete mess of this. I hope I've explained it. The challenge is I only have so many colors, and I'm not the best graphic designer, but this is kind of how it's going to need to work. Remember, this was a single pole, single throw, but we need a double pole, single throw. So we're using 2 of these relays, and since there's a lot of wiring here, we just have to dissect it and make sense of it all. But I think we've accounted for every single wire that we have. We've accounted for all of these wires. We've accounted for all of these wires. We've accounted for all of those wires. So now there's nothing left but to connect everything, okay? And we'll screw this to the bulkhead of the little cabinet up front, and we'll start bonding this. I'll leave this drawing here, but we'll go to the front, and if we need to see what I've done, we'll come back over here and I'll point to where it's at. The part I think might be confusing, perhaps, is on this module here, these wires. But again, we've got, I had my drawing and I erased it, but we did talk about the colors here. So we're going to have red, yellow, and brown. Red, yellow, and brown. We're going to tie all those together as 12 volts plus. Okay? Red is going to feed the module. Yellow is circuit number 1, and brown is circuit number 2. And it's just sitting there. We need them all 12 volts. When we push circuit number 1, then we're going to get 12 volts coming out on green. When we push circuit number 2, then we're going to get 12 volts coming out on white. And of course, in this one, the black is ground. Okay? Over there, the black is plus. On this one, they have red as plus. So you'll see that's the part that the colors change on us. The colors and what the circuits are. So if you take your time and map it out, it should make sense. So let's bring you over to the front and we'll start wiring this in. Okay, you excited? Now what I've done here is I've created what I will call an electrical manifold, okay? Oh my gosh, Darren, all these wires. Oh, okay, well, but just hold on for a second. Let's take a look at this. Remember our schematic from before? 12 plus, okay? So all I have to do is put a 12 volt plus on here and they're all wired. Remember when we did our schematic, we said that we have to wet one side of our normally open contact? Well, what's the other side of our normally open contact going to be? The blue wires. So let me just get the blues out here. Okay. Here we have on the blues an up, a pump, and a down, corresponding to the green, the brown, and the blue in here. So if the reds are all wet, and the remote control is going to be the signal for these relays, that means I'm going to have a double pole signal coming out of here. One's going to be up, one's going to be my pump. And I'm going to have a double pole signal coming out of here. One's going to be down, one's going to be my pump. So already we've simplified some of this wiring, haven't we? I basically tie down is the blue wire down here. So I tap into my blue here. I tap into my brown here. And I tap into my green here. Okay? That's the power side, the normally open and the normally closed side. For our control circuit, we have all these need to be ground. So I've got a ground circuit here. That leaves these blacks. Okay. And I've got one that's set. Remember, that was coming back, I think, on, where's my schematic? Brown and white, I think. So we have an up signal, up SIG, down SIG. So coming back from my control module, where is that thing? Right here. Okay. Wire goes there, wire goes there. So we've made this thing really simple, haven't we? Now I like these Wago connectors. Again, I'll make links down below for all this stuff. I'd like you to be able to do this to your own trailer. Another feature that I like about these is they all bond together. And they all have these little fancy connector things. But I can also put fuses in to protect the circuit. Now I went with a 5-amp fuse, and I went with the fuses that if they fail, they light up. So if I'm out here working one day, I don't have to spend time troubleshooting. I can just look to see that the lights are lit and I have a blown fuse, and I'll keep some spares. So my plan, guys, is to mount this here, just like that. Now this module that's got the radio antenna in it, I'm going to mount it right here. I'd really like to put it on the outside, but I don't think it's rated for outside. So these are going to be mounted right there. And I was thinking about using rivets on these, coming from the backside in here. So that means that these wires here, I'm plenty long enough to make all my connections, and I'm pretty long enough to make my connections down here, and everything's right there. And then, if this is over as far as it can go, then when I get that circuit breaker that I want to get, I'll be able to put it right here. So my back wall will be all my controls. So what I do now is I'm going to drill some holes and rivet these in place. And then I'll drill some holes and rivet that in place as well. Once that's done, then it's just a matter of making our final connections. And once we make our final connections, we can test this thing. Okay? So I'm going to put some rivets in. So now to finish this up, all we have to do is just tie in all these wires together, right? So I've taken a white wire. It's going to my grounds. We can tuck the ground back out of the way. I'm going to come over here, and this black wire down on the bottom of my solenoid we've established is already ground, so I can just piggyback this ground right off of this one. So I've got these connectors, they're piggyback connectors. So now I've got a piggyback end on it. And I'm going to feed him underneath everybody, bring him over to this guy here. I'm going to disconnect the bottom ground, connect their ground to there, and then push him back on. There, now I have grounded my circuit. We've established that down is blue, so down is this one right here because I wrote down on it. Okay, so we'll take a piece of blue wire, tie him into here. And put him over there. Bring him around. About that long would be good. And put another one of these piggyback connectors on. Now, you might be asking yourself, well, Darren, aren't you backfeeding? Isn't this backfeeding the pendant, or isn't the pendant backfeeding this? Well, it kind of is, but again, those relays are open. Remember where they're normally open? So on the relay, you've got 12 volts wetted on one side, and it's when they close that it passes through. So if it's not closed, then it really wouldn't matter if the pendant was pushed and it backfed everything over to the open side of the remote control side, because the contactors aren't closed. Now, it could be argued that somebody could push the up button on the remote control and somebody could push the down button on the pendant. Yes, that's true. And were this like an industrial setting, we'd have to wire a circuit so that that wouldn't ever be able to be, it would be a mechanical and an electrical interlock. But since this is just my trailer, I don't think that would happen, so I'm not really going to worry too much about it. So then that leaves this green circuit. Which is up. And here's up. All the more reason to label all your wiring before you do it, so that when it gets in there and it gets kind of crowded, you can just look at your wiring. So we're looking for the blue up right here. Okay, so he's good. That leaves the brown here that goes over here to the pump. Now that guy, I'll put an eyelet on the end of him. So he's brown. Got brown wire. Here's brown wire. So this one goes to the pump. Okay, took him up there, and we'll bring him around over here. And get an eyelet for that. Oh, how about he's just a little bit too small. I might need to wallow him out a little bit. Let's make him a little bit bigger. Okay, so instead of an eyelet, I'm going to use a fork terminal, and that'll get on there. The eyelet I could have used, but the eyelet I would have had to have drilled out him just a little bit bigger. Oh, what size is that? Never know if it's standard or metric. I wish they would figure out. I prefer metric just because it's a lot simpler than these fractional type things, but they don't ask me. They don't consult with me. So that's actually a 3/8. No, it's not. I'll bet you it's metric. Yes. Okay, we're back with metric. 10 millimeter. Now, where is, we are, now I've taken my battery off, so everything down here is not energized at all. Actually, since it's a fork terminal, I don't need to take the screw all the way off. We're just gonna put them in like that. Okay, so we're going to pick up our 12 volts. Now, remember in the pendant, in the very beginning of the video, we talked about the black wire here that goes to the pendant having 12 volts. So since he's already got 12 volts on him, I'm going to make that the same circuit that feeds everything else. Okay, so now remember, we have quite a few things to energize with that guy that goes up to the remote control feature. So it's a little small wire. The challenge here is the black wire here that's plus, I would need to take my lug off down. It's kind of hard to get to, so I'll just work on it here. Now let's see here. I'll go with red. I'll keep red being my main power circuit here. Red being plus. They changed it to black, but I don't know. It just makes sense to me that red is plus and black is minus, but again, they don't consult with me. So there's that. Now, here is this one. There's really no reason to leave this long. So this is the wires that had this in it, so I'm actually gonna cut him. We don't need all this extra wire in here, so if I cut him that length, that's good. Okay, we're gonna cut this off. We don't need that. And we'll skin this a little bit. So we had said that we wanted red, yellow, and green, correct? Is that the ones we wanted? Well, here, let's just look right here. We want red is 12 plus, okay? And we want yellow and brown. That was what it was, brown. Okay, so these three here need to be 12 volts. Let me get my smaller wire strippers. Okay. Red, yellow, brown. Okay. I'm just going to screw them together to make one wire, and I'm looking for something that may have fallen. Here it is. Okay, so we're going to put him in there. Okay, and then this red wire needs to go down to there, so if we make them that long, we'll be in good shape. Oh wait, no, this guy goes over here. We're fine. Okay, so there's all of our pluses. And we need to get the two blacks that I stripped. We need to get them in here. I'm going to twist them a little bit to get rid of some of the whiskers on them. Okay, before I put them in, let's get these guys going. Okay, so we've established that black is going to be ground, which goes back over to here. And do I have it available? Okay, so we need to, I might make black a little bit longer. Yep, and I can make green a little longer too. So I tell you what I'm going to do. Let me strip some of this jacket off a little bit more, and we can you know, wires could go to different locations. Okay, so red, yellow, brown is going to go into this guy here. Okay, so he's 12 volts. And then we've established that what we need to determine is, okay, we have a circuit 1 and we have a circuit 2. I'm assuming, but I do not know, that A will be 1 and B will be 2, but we don't know that. So we're going to we'll have to figure that out when we actually energize it. So green is going to be 1. So green was going to be up. So that's the up signal, right? And the up signal was this black wire right here. Okay, I want to come under you. This was the up signal. It's caught. There we go. Okay, so the up signal. Okay. And then white was, we're going to assume, is a down signal. So here I have this wire labeled down sig. Okay, there's that. Leaving me with this black wire that goes to our wireless is going to be ground. And let's see here, I've got ground back over here. I don't make it a habit to put 2 wires into these Wago connectors, but I want to see if it'll hold. Let's just try. So I've got it clamped. Yeah, see, it didn't grab. Okay. So let's see here. We got to find a ground. So all of these, remember the thing I called my wiring manifold? They're all accounted for. All my wires are accounted for. Okay. And I do the pull test on everybody, and everybody's happy. So we're going to stow him up in there. So that leaves the black wire. Where am I going to get a ground from? Let's see here. We can go there. Oh, I know. Okay, cool. So remember how on this side I did a piggyback connector? Well, I'll use a piggyback connector right over here. Now the challenge is, all I've got for piggyback connectors are the blue ones. I need a red one. So all I can do is crimp. I'm going to crimp them on the red dot of this crimper. If not, we'll need to come up with another solution. I've got those connectors like phone connectors, and I could use those. But if this grabs tight enough, I'm okay with that. Yeah, it is good. So the bottom part of our solenoid here is the bottom part of our solenoid is ground. So that's where we'll get our ground from. Okay. So let me bring him around here. There we go. Okay. Now, okay. So the last 2 wires are these 2 black wires down in here that went to the pendant. Okay, everybody's connected. Everybody's connected, everybody looks good. All that's good. So the rest of this, I'm ready to connect it. Now, it might be good. I know my wiring is good, but I think there was some programming or some jumper switches or something we do inside of this to tell it what to do. So I'll take a moment and review what the settings are supposed to be inside of this module. But the wiring part of it is done. We basically follow the schematic, and we do a little pull test on these wires, and they're good. Okay, so I'm going to pause, figure out what the jumper settings need to be, so that when A gets energized, he turns on my up, and when B gets energized, he turns on my down. So that's what I'm going to do, some homework on this, and get that part figured out. Okay, it's graduation day. It's time to find out if everything we did works. So we've got our switch on. We did that in video number 2. We've got that up. So I'm going to push the down button, and down works. Push the up button, and up works. So everything that we've done with all of our wiring hasn't compromised this connector. So here's a big test. Connector is here. Now I read in the directions, the factory default is a momentary push button, and I read in the directions that A is 1, circuit 1, and B was circuit 2. So I'm kind of partly nervous because we've come so far, but I'm also confident in my wiring, and I'm confident in my schematic. I'm pointing to it. It's right there. Here goes everything. I'm going to push A. It should dump. I'm going to let go of A, so that worked. I'm going to hit B and see if it comes down. Okay, that's kind of exciting. All right, so let's come all the way down. I'm going to use this now. It's kind of cool. Very good. And then A to extend, or to lift. That's wonderful. It's very good. I want to see how far I can go with this. So you won't be able to hear me. I'm going to set you up so you can watch this thing, and I'm going to walk a decent interval away and see if the radio will still pick it up. So I'm going to stack the deck against me. So I'm going to close that, and let me move you back a little bit. That way you can see this. And then I'm going to walk. I just want to see how far this thing will go. It said it was a long-range transmitter. So let's see what it'll do. Okay, so I've taken my lavalier off, so the sound is not as good. But I'm going to go walk to the driveway over there just for fun and see if this transmitter will transmit that far. Well, folks, thanks for hanging in with me this long. I'm at the end. I'm gonna finish all 3 videos with this statement that in the beginning, when I started video 1, I was going to do it all together as one. But then as we started to develop more of the explanation on things, I felt that could add value to you. We broke it up into 3 parts. So this one was a little bit more involved, but I wanted to go through some of the schematics on my, here we go. The diagram. I hope that didn't confuse you and that made sense to you. I'll also extend this to you. If this is something you'd like done to your dump trailer, but you're just a little bit overwhelmed with all the wiring, shoot me a text message. Well, shoot me a comment and let me know, and we might be able to work something out where I can do all the design work for you, and you kind of pay me for all the wiring and everything, and then I kind of make a kit that you just kind of connect to your dump trailer yourself. More than happy to do that for you. I mean, we're going to have this arrangement where you pay me and I design it for you. You know, I'm not doing it for free. So I'll totally extend that out to you guys. I can probably make these a little bit more simpler. This was done with just stuff that I had here in the shop. And if I were to do this again, I think I might either design my own or see if I can purchase a double pole wireless remote control thing. And by doing that, I would eliminate that little wiring manifold I had to do. Not a problem. Having that does add some extra diagnostics features because we have those relays, those fuses, etc. But either way, I'm more than happy to design one for you and then mail it to you with simple wiring schematics built specifically for your dump trailer. So more than happy to do that. Well, I'm kind of excited that at the end of this, I was able to put my battery in a battery box. I was able to do the disconnect switch, and I was able to operate the remote. And I was able to go pretty far away to the other end of the driveway down there and operate the thing farther than I would ever really operate it. But I was doing a test, so it is a long-range transmitter. So I'm pretty impressed. And I went to the back, so it had the signal had to go through the metal of the bed and through my closed box. So even more so, I'm really impressed with the frequency range of that wireless remote control. You've hung out with me this long. I'm almost out of sweet tea right there. If this was helpful, give the video a thumb up. That's really helpful. Subscribe to this channel. Around here, things are kept simple, and we're going to be doing more right along here. We're going to be doing a driveway, and we've got a lot of other projects we're going to be doing, and so want to add value to you. So, hey, give us a thumb up, subscribe, leave some comments below. Thanks for watching. So, from Kepp Simple, this is Darren, signing off until the next video.